Hey everyone, welcome back, and today let's solve Leetcode problem 1942 titled The Number of the Smallest Unoccupied Chair. So there's a party where n friends numbered from 0 to n-1 are attending. There's an infinite number of chairs in this party that are numbered from 0 until infinity. When a friend arrives at the party, they sit on the unoccupied chair with the smallest number, or the smallest positive integer, including 0. For example, if chairs 0, 1, and 5 per se are occupied when a friend comes, they will sit on chair number 2 because that is the chair with the smallest possible number that's unoccupied. When a friend leaves the party, their chair becomes unoccupied at the moment they leave. And if another friend arrives at the same moment, they can sit in that chair. So we're given a 0-indexed 2D integer array times, where times at index I is equal to a pair or an array of length 2 with arrival at index I and leaving at index I, indicating the arrival and leaving times of the ith friend respectively in that integer array times, and we're also given an integer target friend as one more input or parameter. All arrival times are distinct, and we have to return the chair number that the friend numbered target friend will sit on. So in example 1, we have times to be an input array of 1, 4, 2, 3, 4, 6, and our target friend in this case is going to be 1. And we would output 1, and the reason why is because we know that friend 0 is going to arrive, obviously, at time 1, and he's going to sit on chair 0, basically the chair that's unoccupied with the smallest possible number, starting from 0. Friend 1 then arrives at time 2 and sits on chair 1, the next unoccupied chair with the smallest number. Then at time 3, friend 1 is going to leave, and then chair 1 then correspondingly becomes empty. And friend 0 is going to leave at time 4, and then chair 0 would also become empty for that reason. And friend 2 arrives at time 4 and sits on chair 0. And since friend 1 sat on chair 1, we can return 1. Okay? So note that when we have an input array times of length 3, we know obviously that there's going to be 3 friends, because that's going to tell us how many friends are attending that party in every corresponding test case, the length of the times input array. So in example 2, we have the input array times to be 3, 10, 1, 5, 2, 6. We also again have 3 friends, and in this case our target friend is 0, and so we'd output 2. The reason why is because we know friend 1 is going to arrive at time 1 and sit on chair 0. Friend 2 is going to arrive at time 2 and of course sit on chair 1. Friend 0 arrives at time 3 and he's going to sit on chair 2, the next unoccupied chair with the smallest integer value. And friend 1 is going to leave at time 5, right? And the chair 0 would hence become empty once he leaves. After that, friend 2 would leave the time after that at time 6, and then chair 1 also would become empty. And then finally, friend 0 would leave at time 10, and chair 2 would hence become empty, right? So basically, since friend 0 did end up sitting on chair 2, that would be our final answer of 2, because of course our target friend is 0. So with that problem statement out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Alright, so to solve this problem efficiently, we're going to be using 2 main data structures, including a priority queue or a min heap to track available chairs. And we'll also use another priority queue to track the guests currently seated, sorted by when they actually leave. So to better structure how the solution is going to work, we'll first sort the guests by their corresponding arrival times. And as guests arrive, we'll assign them the smallest possible chair from the heap as defined in the problem statement. And when guests do end up leaving, their chairs will become available again, and so we can push those chairs back into the heap. Okay? So with that out of the way, let's just go ahead and dive straight into the problem here. So I'm going to basically initialize a times array. I'll set times. And I'm going to initialize this to basically be an array of times at index I at index 0, because we know that this is a 2D input array times. And we'll also have in this tuple, I should say, times at I and 1, and we'll also have finally the index I itself, and this is all going to be in the range, for I in the range of the length of the times input array. Okay, so to better explain this, we're basically going to modify the times list, not just to include the arrival time and leaving times, but also the index of each guest. And this is basically going to help us track which guest corresponds to which chair, or better yet, which index. Okay? Once we do that, I'm going to sort the times array, and I'm going to pass in a key. In this case, for my key, I'm going to actually use a lambda anonymous function, and in Python, that's very easy. For lambda functions, I'll literally just have to say lambda, and for my two, per se parameters, I'm going to take an x and sort by x at index 0. And I don't know if we have to have a space here between lambda functions and their parameter initialization. I will, just to make it a little bit more readable, but that's basically how lambda functions work in Python with keys and sorting methods. Okay? Again, we're basically sorting the times list in this line by the guest's arrival times, right, as denoted by any interval x at index 0, basically the starting arrival time in every pair. And sorting is essentially going to help us process the events in the order that they actually occur in, right? Because that's obviously how we want to process or parse through this array. Now we'll actually have our free chairs array. Actually, I'll capitalize chairs. And I'm going to initialize this to be an empty array. So basically, we're going to initialize this free chair as an empty list to represent the chairs available for assignment. Okay? Once I initialize that variable, now we also want to initialize our occupied chairs, which I am also going to initialize to be an empty list, right? And this heap is basically going to store tuples of leave, time, and chair number for guests who are currently seated. And when a guest does leave, we'll know which chair becomes free. Okay? So once I do that, I'm going to basically loop through, again, the indices of the length of our times array that we built up on line 3 for I in the range of length of times in Python. I'm basically going to heap q.heap push. That's the syntax for it in Python. Okay, I don't actually need. I think it's 2 P's. Please feel free to correct me if I'm wrong. I think it's heap q.heap push, and I'm going to basically push onto the free chairs heap. And for the value that I'm pushing in, I'm basically just pushing in the index I. Okay. Again, in this loop, we're basically pushing all the chair numbers or indices from 0 up until n-1, where n is the number of guests into the free chairs heap. And of course, initially, all chairs are obviously going to be available. Okay? So once we actually build up our free chairs array like this, now we want to actually loop through the arrival time. So for arrival, and I'm going to say leaving, and I could say index, I'll just call it IDX for short, in the times input array. Because note that we have in the input array in the array times that we built up, tuples of length 3 that we used. Basically, you can say as tuple comprehension as we loop through the input array length of the times, right? So basically, for arrival, leaving, and index in the times array that we built up for all the different guests, we have to do the following. So basically, again, to better explain what this does, we're basically going to process each event one by one. And now we're going to have a wide chunk of code, basically to ensure if any guest has already left by the current guest's arrival time in the current iteration of our iteration or traversal of our input array times. So I'm going to say, while the occupied chairs is not actually non-null, or basically it's not empty, and the occupied chairs, okay, I really can't spell today, at index 0 is less than or equal to the arrival, then we know that we can basically set leave time, I'll just say leave time, and I'll say chair number to be equal to the heap q dot, I think it's heap pop in Python, heap pop. I really do think there's 2 P's. Feel free to correct me if I'm wrong. And I'm basically going to pop off of our heap the occupied chairs. Again, I'm basically just popping off the most recent element of our occupied chairs heap. And then from that, I'm going to heap q dot heap push onto my free chairs heap, my chair number. Okay, okay, I'm trying to type a little bit slow just to make sure I don't make any syntax errors, and so you guys can understand the code as well. But again, what this does is, like I talked about before, this basically is going to ensure that if any guest has already left or is already gone by the current guest's iteration arrival time, then we know that their chair is freed up. And so we can pop these guests from the occupied chairs heap and push their chair numbers or indices back into the free chairs, making those chairs available again for future iterations in our traversal of our infinite array times. Okay? And once we actually do this, now outside of our while loop, but still, of course, within our for loop, I'm just going to get 2 spaces down. I'll set our chair to basically be equal to, again, the heap q, I think it's dot heap pop, and I'm going to pop from my free chairs heap. Okay? And what this basically does is we basically assign the current guest the smallest available chair by popping from the free chairs heap. And since it is a min heap or a minimum heap, this does ensure that we get the smallest number chair. That's why maximum and minimum heaps in Python are very, very useful and helpful data structures. Okay? So once we actually pop from our free chairs heap, we want to then heap q. We want to then heap q dot heap push onto our occupied chairs the tuple of the leaving and the chair. Okay? What this does is it basically says once a guest is seated, we can push their leaving time and assign the chair into the occupied chairs heap. And this helps us track when this chair will actually become available again. Okay? And that's basically what line 15 is doing. Okay? And just to make sure I have the syntax correct, by chairs, I think that should be good. Again, I don't know. I think it is heap q dot heap push and heap q dot heap pop. We will get to know once I actually submit the code. But once I actually basically push this onto our occupied chairs, now I basically have to have our conditional after I do this. If the current index, if that's actually equal to our target friend, our parameter as such, then we know that we can return the chair. Okay? And again, basically, if the current guest is actually the target friend, basically the guest whose chair we actually need to track, then we can return their assigned chair number as the solution. Okay? So unless I made any syntax errors here, this should be accepted and this should be submitted. Okay, yeah. Module heap q. I think. Let's see what I did wrong here. Oh, okay. So there should be 2 P's. That's good to know. Let's check where I actually didn't include it. Okay, yeah, right here. So there should be 2 P's here. I probably made another very, very dumb spelling mistake or something here. But as you can see, this is actually just about as efficient as you can get, and it is actually accepted. So before we actually get into the time and space complexity and the efficiency of this code, let's just kind of reiterate what the overall code actually does, right? So I'll try my best to keep it as concise, but as detailed and important as possible, right? So this code basically processes each guest one by one, and as each guest or as they arrive, we'll assign them the smallest available chair and update when the chair will become available again after that corresponding guest leaves. And we'll use 2 priority queues or heaps as such to keep track of available chairs and occupied chairs. And the key challenge is basically making sure we efficiently assign the smallest available chair and update the state as the guests leave. So for the time complexity of this code, this is going to be big O of n log n, where n is the number of guests, because, of course, sorting the times list as we build it up from our input array times is obviously going to be a big O of n log n operation. And basically, for each guest, we perform a few heap operations, push and pop, which are big O log n. But since there are n guests, the overall complexity is going to be big O of n log n for the runtime complexity of this code. And for the space complexity, this is going to be big O of n, because we really only store information about all guests in the times, free chairs, and occupied chairs lists, and each of them can hold up to n elements. So technically, this would be worst case big O of 3n, or 3 times n, for the space complexity. But as we have talked about in previous videos on this channel, coefficients in runtime and spacetime complexities don't really matter because they don't really change or modify the efficiency of your code very much. And so to a certain extent, you can basically ignore them and simplify them to basically be the variable part of each runtime and spacetime complexity, right? The coefficients don't necessarily matter, right? So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.